Hello everybody! There are many tutorials on YouTube how to use a multimeter. I kind of do not agree with one claim which echo in many of those. In my video I will challenge this claim, but first, let's see what they say.
Always connect the black wire to the neutral first, because if you connect the red wire to an active terminal first, the black wire will instantly become electrified.
Because if you put one end in like that, then this other end has become live. So just be aware of that. You might come a gutser and that'll ruin your day. Very dangerous.
You do not want to start off with the red probe or take out the black probe with the red still attached to the hot side. If you do that, that can cause a safety issue, and let me demonstrate that for you. So now even with the probe just sitting out here, because I have my hot side connected up, my non-contact voltage tester indicates that this probe right here is live. So that is equivalent of sticking a knife in the hot side, sticking a wire in the hot side, and now this is live and obviously can arc against anything that would ground it.
When testing live voltage, it's essential to use caution. Always start with the neutral wire first before connecting to the hot. If you connect to the hot side first, the other multimeter probe now becomes energized, which increases the risk of a shock.
So why is that? Well, if I stick that red probe in and I have this other side here, we'll use the non-contact voltage tester so we can see that we have a situation that might be dangerous with this probe depending on what we touch it against.
When placing the probes, the other could become instantly electrified, so do not come in contact with the probes after placing them in the socket.
Here I have a modern digital multimeter with probes plugged in. No funny business here, no AI, all real stuff. I turn it on into AC voltage position. It is picking up some noise, but in fact no voltage present. A power bar switch in off position. I plug the red sound into hot outlet, black to neutral. We care for good connection here. Power on. Over 120 volts present. Now I remove the black sound. The red plugged in and the power bar is energized. According to YouTube tutorials, this end is live. Let's see. Here I have a tester and turn it into function that works by contact with tested point. No tricks here. Neutral, nothing happens. No voltage detected. Good. Hot side, we have a beep. Let go. How can I keep it in frame for you? I will touch the exposed sound end. Yep, beep, red light, H on display. We have live voltage there. Neutral, silentium. The red sound, live voltage. Danger. Now the black sound. Sure enough, it is energized. Once again, we read 120 volts. No fooling around. So we can assume that it would be dangerous to touch. I didn't disconnect anything. But I'm touching it, and I'm not shocked. Any trick? AI? Or should I ask myself a question?
Do I feel lucky, punk?
Here I have a second multimeter. The yellow one turned into AC voltage. the red one in ohm meter. Technically, the ohm meter can measure resistance, not impedance, but it will give us general idea of the internal impedance level. It shows around 10 mega ohms, while the owner's manual specification is 5 mega ohms. Over 11 mega ohms on DC voltage mode, the manual says 10 mega ohms. In general, we prefer the voltmeter to have very high internal impedance. I explain why in my video about an invisible voltmeter. This specific meter is equipped with low Z function. Not lousy function, but low Z function, low impedance. And here we measure over 3.3 kilo ohms. The manual says 3 kilo ohms. In some situations, this low Z function is useful. I explain such cases in my invisible voltmeter video. Watch it only if you are not afraid of ghosts. Switched into amps position, and here we have hardly any resistance. Basically short. Should be like this. Let's turn the tables now. Red, AC volts. Yellow, ohm meter. Same story. We have mega ohms here. This meter's manual says internal impedance for AC voltage is 10 mega ohms. DC volts position, and we have again mega ohms. Majority of digital multimeters have internal impedance in mega ohms. Next multimeter. Resistance is so high that the fluke sees open circuit. The manual for this meter says 10 mega ohms for AC voltage. Over 11 mega ohms on DC voltage mode. Cheap DMM. Reads in mega ohms. Didn't check the manual. Hold on a second, I have somewhere really cheapo multi. Even this junk tests in mega ohms. The manual long gone, but still, it reads mega ohms. I would not trust it though. Let's measure the current in this voltmeter loop. The yellow meter in AC voltage function. The red one will read AC current in milliamps. Power on. 120 volts in the power bar. Ammeter hardly sees any current. Let's switch it to microamps, AC. Over 24 microamps. This is very low current that we cannot even feel. I turn it back to milliamps function. AC. Now I switch my meter to low Z voltmeter function. And this is dangerous current. At this level, muscles will contract, and one may not be able to let go of the conductor. But it is special case and not many multimeters have this function. The current is high enough to produce heat. Resistance goes up and the current drops. Initial current spike is high, and yes, It is dangerous to touch. I would not dare. This old meter has 20 kilo ohms per volt. Before touching the probe, I not only did measurements but also made calculations. Better safe than sorry. Here we have traditional North American outlet of 120 volts. Live side. Neutral here. The sound plugged in the live side goes to the voltmeter in our multimeter. Internal impedance. I draw a resistor, but let's keep in mind it is RLC. In Fluke 117, it is 5 mega ohms. The other sound goes out of the meter. If we close the loop, the current that will flow in the circuit will be limited by this impedance. To measure current, we need an ammeter. Its impedance is basically 0 ohms. I close the loop to the neutral. The current flows through both meters. Let's calculate it. Five mega ohms is 5 million ohms. 5 with 6 zeros. According to Ohm's law, the current will be 120 volts RMS divided by 5 million ohms. Oh, my pen froze. This gives us 0.00024 amps. In short, 24 microamps. And this value we were reading on the ammeter, if you remember. But it was with 5 mega ohms internal impedance. It is a different story for low Z function. At this function, the internal impedance for the voltmeter is 3.3 kilo ohms. Let's calculate the current drawn by the voltmeter. 3.3 kilo ohms is 3300 ohms. Let's apply the Ohm's law. 120 over 3300 0.036 amps. In short, 36 milliamps. It is not much, but still enough to impact one's health. So modern digital voltmeter will not pose danger. Different story for the special case low Z function. In either way, do not touch it. I did it so you don't have to. And yes, it is a very good advice and a habit to have, and not touch any exposed conductors, even if you assume the power is off. Probe with one hand and keep the other in the pocket. Moisture, compromised insulation, you name it. One probe with one hand at a time. Better safe than sorry. Till next time.